This is questions 1 and 2. They're both about balancing on chapter 3. So, first question, it's a combustion uh, experiment, I guess. Reaction, there we go. So they give you this little MBTA, I think it's called C5H12O. Combustion reactions are always going to be oxygen. Don't forget oxygen's O2. And they're always going to give you a product of H2O, water, and CO2, carbon dioxide. That's just what happens when stuff burns. So, just like any other balancing problem, count out what we have. Your subscripts, which are the numbers right here at the bottom, they're going to tell you how much you have of something, and then your coefficients, you're going to have to multiply to figure out the whole total, I guess. So here, you could say my coefficient is 1, so C5, it's just going to be 5. Sometimes you're going to have a 2, maybe, it depends. H12, you got just 12. Here you got 1 oxygen, 1 times 1 is 1, plus 2, because 2 times 1, I'm just not putting the 1 here because I'm kind of lazy, and then it looks like a 10. But here, you got 2 plus the 1 here, that's 3 oxygens. Over there on this side, I'll put them the same way, CHO. You got 1 carbon, you got 2 hydrogens, and you got 1, 2, 3. 2 from here, 1 from here. So you got 3 oxygens. Now what we can do is change the coefficients. We can't change the subscripts. So what I can do right here right away is 5 to 1. Easy stuff. Just put a 5 right here. And now, because this is C just by itself, that means it's got a subscript of 1. 5 times 1 is 5. We're good to go. It's the same. H12, well, I can bring this up from 2 to 12 by multiplying by 6. Now this is H12. And now I actually have to count my oxygens again, because by moving the coefficients from 1 to 5 and 1 to 6 right here, I also affected the number of oxygens. So if you remember, I mentioned you multiply coefficients by the subscripts. 5 times 2 is 10, and then 6 times 1, there's no subscript, it's always 1. 6 times 1 is 6. So 16 right there. So here I've got 3. What I can do is, right here, I've already got 1. So 15 is really all I need. Now, the problem here, oh man, I wish I could put 15 right there. The problem here is that oxygen is diatomic. So for me to actually get 15 from this oxygen, I would have to divide by 2. And this would give me the coefficient that I need to actually have 16 on this side. Because if we do a little math right here, 15 over 2 times 2, well, these guys cancel out. You got 15 plus the 1 oxygen here, you got 16 oxygens. Now, because we can't have coefficient as a fraction, what we're going to do is just multiply everything by 2. That way it'll be even and it'll cancel out. So these numbers, for example, C5H12O, we're going to do doubling. So originally it was 1, now it's 2. So we're going to erase this actually because it's all going to change a little bit. This 15 over 2, like the little math that I showed you guys earlier. 15 over 2 times 2, all right, just cancels out, okay, and you got 15. Just this 15 right there. Then, dang it, you got 6 times 2 is 12. 5 times 2 is 10. There we go. And now we can count it out. Everything should be balanced out. So 2 times 5, carbon, hydrogen, oxygen. 2 times 5 is 10. 2 times 12, 24. And then 2 times 1 is 2. We got these guys over here. So 15 times 2 is 30. Plus the 2 from here, 32. Now, here we've got same thing, carbon, hydrogen, oxygen. 10 times 1 is 10. Okay, so we're looking good for carbon. Here, hydrogen, 12 times 2, 24. Then we got oxygen. We got 12 oxygen from the water plus 10 times 2, 20 from the carbon dioxide. So 12 plus 20 is 32. We'll just double check that real quick. 2, 1, 2, 3. There we go. We're good to go. So pretty big numbers, but I think you guys should pause this video, do the second one. I'll help you guys out, put it together. So we got KO2 plus CO2. Produces oxygen gas, O2. And remember what I said, oxygen is always going to be O2. Plus K2CO3. So this is the equation. It's not balanced. I think that's what you guys should do. So just pause it right here. Try to balance it yourself. Give you time to pause if you're like across the room or something. Okay, here we go. So start off with KOC. Potassium, oxygen, carbon on both sides. Here we can see that we only have 1 potassium. We can see here 2 oxygens and 2 oxygens. So we got 4. And then only 1 carbon. So there you go. Right? CO2, KO2, O2. Yeah, that's right. Okay, and then we got O2 from here. Ooh, and then we got O3. So 3 plus 2 is 5. Potassium, we have 2 potassiums, and then we have 1 carbon. Okay, so really, we're set to go on carbon because they're both 1. Potassium and oxygen are the ones that are going to have to change. Well, to go from 1 to 2, it's a pretty simple fix. I can just multiply times 2. So I got 2 KO2. So now I have, nice, 2 potassiums on both sides. But I just changed my oxygen as well. So we got 1, 2, and then 2 times 2 is 4. 4 from here, 2 from here. We got 6 oxygens. Okay, so we got 5 here, 6 here. Now, whenever you have oxygen, just like we did over here, you can kind of treat it at the very end. This is what you can do. Because we have 6 here, we got 3 oxygens there. So really, I kind of want to Just put a 3 right there. Because 3 plus 3 gives me 6. But oxygen is diatomic, so I can't just put a 3. I have to put, remember, always oxygen 3 over 2. Just like we did here, 15 over 2. 3 over 2 for oxygen. I want you guys putting stuff over 2 when it's not diatomic. Just be careful with that. So 3 over 2, that means we have to, again, multiply everything by 2 so that we can get the correct ratio. So here, I'm going to erase everything again because it's going to change anyway. Cha-cha-cha. 2 KO2 is now 4 KO2. Here I only had 1 CO2, but now it's going to be 2 CO2. I got double. 3 over 2 times 2 is just 3. It cancels out. 3 over 2 times 2. You can plug that into your calculator. It's always going to be 3. All right. Cancels out. So 3O2 plus K2CO3. There's only 1. But now we double it. We got 2. So now KOC, 4. Here, 4 times 2 is 8. Plus the 4 from here, we got 12. And then 2 times 1 is 2. So we got 4 potassiums, 12 oxygens, 2 carbons. Same thing over here, potassium, oxygen, carbon. Let's do carbon right away. 2 times 2 is 4. Nice. Oxygen would be 3 times 2 is 6. Plus 3 times 2, 6, 12. Okay, we're good to go. And then 2 calciums. So there we go, 4, 12, 2. So balancing equations is the first part of chapter 3, and it's actually pretty important for the rest of the chapter 2 because you need it for stoichiometry. So I think it's for sure going to be on the test. Don't quote me on that, for sure though, but I don't know.